So yeah, thanks for coming, everyone. This is actually, because of some medical reasons, this is my first office hours that I'm at, so I'm excited to be here and meet all of you good people. So yeah, we are talking about Bash tips and tricks to use in CircleCI and in life. I am really going to try to double down on the life portion because I think Bash is a versatile tool that we can use in many aspects of our life. For the live tweeters, you can live tweet hashtag CircleCI, hashtag double down on life. But with that, let's get into it. So quick agenda, why use Bash? Okay, since we're going to use Bash, some things to do with Bash. Talking to the internet, because that's increasingly useful. Getting values out of functions. Many of you may know what I'm getting at and why this is sort of hard with Bash, but I'll talk a little bit about that. Handling errors and making things robust. And then a handful of select bonus tips. So first of all, why Bash? It's basically everywhere is the short answer. It's in your terminal, which is your sort of primary interface to your computer probably. Any server, whatever AMI you're using, whatever distro you're using, even if you're using OS X or other operating systems to a certain extent, it's just kind of there. You can, in your user data script on Amazon or whatever your sort of little bootstrap, first thing you do is Bash is probably there. It's very Unixy. It deals with things like pipes and error codes and file descriptors and return codes and all these sort of Unixy things, so it feels very natural to use it on Linux or OS X or what have you. And it can kind of just glue together other stuff that makes up your app or your test environment, your dev environment, just tools you have lying around. It's just kind of good, good glue to kind of stick stuff together. So it's just all over the place, and you can basically, you can try to fight it, or you can just give in and love Bash. And I'm going to encourage you to, where appropriate, give in. So quick show of hands before I go too far. Let's just say, how many of you use Bash on a daily basis? OK, pretty good. How about a 3 or more times a day basis? Yeah. OK, so there's a lot of you. I mean, we're a bunch of happy Bash users. So a few of these things that are kind of in-depth working with Bash, I'm going to just do in one kind of extended example and kind of interactively work through it. And then I'll close out with a few other odds and ends in sort of a mishmash fashion. So let's go ahead and jump into the example. So I'm going to escape and go to my terminal. Whoops. OK. So the first thing I said I would talk about is talking to the internet with Bash. How do we talk to the internet with Bash? Curl, right. That's the great. So if I want to curl google.com or whatever, look at that. We talk to the internet, right? But Google is kind of old school, right? That's very like 2002 or whatever, 2004. So the cool kids are on GitHub these days, right? So let's interact with GitHub. And in particular, I'm interested in what are the cool trending JavaScript libraries on GitHub. So I want to know what are the most recently updated JavaScript libraries, because it's important that we stay in the know about these things. The ecosystem is moving very fast, right? So I have a query here that talks to the GitHub, API to get the most recently updated JavaScript libraries. But look at that. It's this big ball of JSON, right? And that's great. If we were writing a program or something where we were interacting with the API programmatically, we could interact with that. But from our terminal, from our kind of hackable, scriptable world here, how do we deal with this? So some of you may already know about this tool, but there's a really cool tool called JQ that is all about, it's kind of like sed and awk, but for JSON data. So I'm going to use that real quick to make this just a little bit more readable. Also going to suppress the progress. And now look at that. Instead of just a big ball of junk, it's a big colorful ball of junk, which is a big improvement. But I can actually also do other things like ask for just the keys of that first blob of stuff and kind of browse. Oh, OK, here's the object, and then I can kind of drill down into it and so forth. To make this a little faster, I'm going to limit the results to about 10. And let's look at that items thing and see what we're working with. So here are the keys on any given project, and one of these is name. So I'm just going to say, what are the names of all of the top JavaScript, most recently updated JavaScript projects. So these are the hottest JavaScript libraries or projects on GitHub that we need to be clued into to have our fingers on the pulse of the JavaScript ecosystem, right? So already we've improved our life with Bash, I would suggest. And I can also sort of trim this output a little bit with the JQ raw command so that now it's just the strings. So this is like a super useful tool for us developers to stay clued into the JavaScript ecosystem, right? But I want to go a step further. And now that I have that, I'm going to put that into a separate file. I'm also going to just kind of work with some tags here so that I'm not just making typos. So let's check that out and then run it. And it's just the same thing that I just wrote, right? Just saved in a file that looks like this. So I have taken my interactively developed little piped program and put it into a script. And this is actually one of my favorite things about Bash, because there's this kind of fluid transition from working with something interactively in the terminal, piping and running commands and whatever, to then throwing it into a file and then kind of building it into maybe something a little more robust that you either use on an ongoing basis or check into your source or whatever. So I'm going to kind of upgrade this script, though, and make it a little more sophisticated and useful by, instead of just checking once on the hottest JavaScript libraries and projects, on sort of keeping an eye on them. And so I'm going to go to the next step here. And all I've done is created a while loop. And if you're familiar with Bash syntax, just while true is just going to loop forever, right? I've initialized one variable called old hotness to the empty string. And then in this infinite loop, I'm going to say that the new hotness is the result of this query to the GitHub API for the most recently updated JavaScript project. If you're not familiar with command substitution, the fact that this sort of curl pipe JQ is in this kind of $ parens, that's just saying evaluate that, take standard output, and give me that string, basically. Then I have a conditional where I say, if the new hotness is different from the old hotness, then compose a message to alert me about that, and make the old hotness now equal to the new hotness. So, and then just sleep for a second to be nice to the GitHub API. So there is actually going to be an audio component to this. So let's see if this works.
Alert. The hottest JavaScript project is Cookie Storm.
Hold on.
Alert. The hottest JavaScript project is...
Guys, get on this. You got to Google Leo. No, wait.
The hottest
Kilroy calculator.
Project is Kilroy calculator.
Oh, whoops. Okay.
Alert.
Okay. That's enough JavaScript for that 10 seconds. So we've just improved our lives like way more even with just a few more lines of code. For those of you that use Macs and don't know about the say command, that's what lets you just get that programmatic access to the speech synthesizer. So that's great. Now, this is basically functionality-wise all I could ask for in a script. But we want to sort of robustify this a little bit. And I talked about functions. I haven't actually used a bash function yet. I've just used looping syntax, conditional syntax, some tests. I'll talk a little more about tests and test expressions later. But I'm going to actually make a function now. So quick show of hands, who's written a bash function before? OK, so some of you, but maybe about half or so. And I know there's a whole range of levels of bash use here. But bash functions are kind of just a bit different in what they can do than other programming languages functions. So I'm going to check out the next step here real quick. And just kind of show an example of how you might think a bash function would work, where I do basically the same thing. I'm trying to sort of make this a bit more just readable and kind of well constructed. So I'm splitting that whole ask GitHub for the latest JavaScript project portion and putting that into its own function called hottest. That takes one argument, which is the language I'm searching for. And I'm going to try to return that string value of the project name. Now, some of you probably already know what's going to happen, but it says it won't accept pkjudge, which was right then the hottest JavaScript project, as the return value, because return values in Bash are numbers. They're just a number between 0 and 255, I think. They're just an exit code. You'll actually notice that this command itself, because that was an error, returned an exit code. That's what the little red in my Bash prompt is whatever the last exit code is. You can also see it in the $? environment variable, or kind of special variable. You can use the exit command anytime you want to in your own scripts to just say exit with whatever error code. And you can do that in functions too. So both programs and functions don't return strings or anything like that. They just return a number, right? So what I'm actually going to do is show the correct sort of version of the function, or a version of the function that works a bit better, which is to not do any command substitution in the function and to just run the commands, curl pipe JQ. And that's going to just spit stuff to standard out. And then whatever calls the function can take that value and do something with it. Now, there are actually schools of thought on this in different camps about how you should get data out of Bash functions. I like this approach, but there are other alternatives like name refs or writing into environment variables. Why I like this approach is that it's basically treating your functions like little baby programs. So a function can take args, it can read from standard in, it can write to standard out and standard err. You can think of them just like programs, but they're just a little one-off single-use program. Or that's one way to think about it. And you can get output out of functions using command substitution and so forth. So here I am having the function just write to standard out, and then I capture its output using command substitution where I call hottest JavaScript. And just to review that everything is still working fine.
Alert. The hottest JavaScript project is winiml.github.io.
Cool. So we're in good shape. The function works. It's a little more, structured, and that's great. So that's how functions work. But let's now talk about really making things more robust and handling errors. So this is going to work great as long as the whole curl pipe JQ thing works and I have an internet connection. But I've actually done something a little tricky here so that I can basically I have aliased curl in my environment now to be able to simulate a no connection to the internet without breaking the Wi-Fi that currently has my screen functioning, so I can't do that. So I'm going to say internet equals no curl google.com, for example, and I see that when I have that environment variable set, I have a simulated outage here that just immediately fails. So I've sort of kind of given a mock or wrapper around curl to be able to fail selectively. And let's see what happens when I try to run my search script. And it just keeps failing, but it doesn't stop. It just keeps failing and failing. And I might walk away and think that nothing's happening in JavaScript land, but actually my internet is just down. And that's clearly unacceptable because I'm going to be complacent and I'm going to totally get behind the times. So one tool to address this is a option you can pass to Bash called set-e. And putting options up here like this is equivalent to if you run the Bash interpreter like this and add the flag that way. But you can also just set them at the top of your script here. There are some other useful ones. X spits out the command before it runs everyone. U will complain if any environment variable is unset. So you might see those a lot. But set-e is basically one that just says, instead of doing the default behavior, which is just keep on running in the face of any problem, just actually exit when something goes wrong, which is almost always what you want your program to do, right? Like every other programming language does that. It just throws up its arms and says unhandled exception. So let's make that change and see what happens. It didn't work. So that's confusing. Why it didn't work, though, is a little complicated. I'm actually going to do one more thing. I forgot a step, but I'll explain in a second. 5. Oops. OK. I just did one thing, one additional thing, which was to add a bit of extra logging to the script. And this is related to the error handling thing. You'll see why. But basically, what I added to my function was some quick logging of the raw output from github.com before returning the result. So real quick, what that looks like in the functioning form is
Alert.
that.
Hottest JavaScript.
OK, that's enough. So it's just printing. The function's doing a bit of logging in addition to returning its output to standard out. And this could be useful for lots of reasons in any function that you might write, just to sort of have the function write some output. What I had to do, though, was have it write to standard error so that the output would still go to standard out and be accessible when I called the function. This is similar to like what curl does when it prints the status to standard error, but it doesn't put that in the standard out because you want standard out to just be the response body. You'll see why I did this in a second, but just pretend that that is useful, so let's just keep that there. But still, set-e is not going to help. It's just going to keep failing and failing. You can see that it's not, the result's empty, right? So set-e doesn't help. There are actually two things we have going on that are problematic. We have a pipe from curl into JQ, and error codes don't propagate through pipes by default. So by default, only the error code of the last thing in a pipeline is returned or worried about, but we have a curl error that we want to propagate through. So there is a way to handle this with set-o pipe fail, which handles exactly this case. And so now I can rerun that failed case, but there's still some issue. And what it actually is that set-e doesn't go into command substitutions. So it's this guy here, this command substitution, where set-e is unset, just because. I really can't say why, but Bash decided that would be a good idea. So if I double down on set-e and tell the command substitution again to actually do that, then we see we promptly fail, and we're alerted as to not being in the loop on JavaScript, which is the whole goal, right? So set-e is great in theory. There is a, like in the function returning values case where there are two camps, or there are multiple camps on how to return values from functions, there are also multiple camps about whether or not to use set-e. Some people argue that you should handle all your errors manually because the behavior is so weird. I think I prefer, go ahead and set it, but just be aware of this weirdness. Things like pipes. Remember that any test like this while or if those tests are not going to trigger an error, right? The test can fail, but that won't fail the script. And there's a whole command substitution thing. There's something called Posix Mode where if you enable that set-e propagation thing is fixed, but it also just sets 50 other things that, kind of randomly, so you probably don't want to use that. So the point, though, is that set-e is great, use it, but beware of some of the issues that can still happen even if you have that set. So that was the quick set of sort of things I wanted to cover in the specific example there. Time-wise, I'm out. I think I'll just do a condensed version of the remaining slides. Does that sound good? Or shake head, nod head? Good? OK. Thomas, this is for you. So let's go back into play mode here. OK, so a couple other quick bonus tips. Quote everything. Almost everything should have quotes around it. This is an example where I pass an environment variable A into the touch command and then use it. And the environment variable is set to foo space bar. But instead of touching a new file called foo space bar, it created two files, one called foo and one called bar. Because that unquoted $A got word split, which is what bash does to any unquoted string with spaces in the middle, and got turned into two arguments to touch, which meant to touch two files. So if I quoted it like I do in the second case here, I get one new file now called foo space bar. There's lots of, like, a lot of times you would be fine if you didn't quote, but there's so many just weird subtle things that it's basically just a good practice to always quote. Addendum to this, even quote $at. And $at, if you don't know, is the array of all of the arguments that are passed into a bash script. And it's argv, basically, in C terms. And some people are confused about this, but if I pass into my script foo bar space baz in quotes quux, and I don't quote at, it looks like 4 args. But if I quote it, it's not word split, quote $at, but it's sort of argument split. So it's kind of this special case of how bash handles strings with spaces in it and stuff. So it's split kind of just right. It's split into what the args that were passed in are. I don't know if if arg splitting is the right term for it, but it does the right thing. So even quote $at. I think arrays work the same if you're doing stuff like this with arrays. Couple more quick things. Double brackets are better than single brackets. Single brackets are a test command. A single bracket is basically equivalent to the test command line function. This is another bonus tip that man test is super useful to give the man pages for all of the different -z, -e, -d, all these different tests that you can do. So this says test if path is not empty and foobar is empty. So path should not be empty and foobar should be empty. And it fails because you can't combine multiple expressions in single brackets. But in double brackets, you can. I can say, chain all these tests together and tell me the output. There's other good things about double brackets. Word splitting doesn't happen in them. There's a kind of regex syntax that's not Posix compliant, but you can use it in bash. That can be really handy. So there's just better to use double brackets. Final bonus tip, and I know this talk was supposed to be about CircleCI, using bash in CircleCI and in life. We kind of ended up heavy on the life side. You know all about how to stay in the loop on hot JavaScript frameworks, so I hope that's a really good takeaway for everybody. But I would be remiss if I didn't point out at least some of the cool things you can do on CircleCI. So generally, you can just use it normally. Notice the echo command here. It looks like just normal bash because it is. And every command in CircleCI is just bash. You can call scripts like you can call any other program. If things get very big and unwieldy in an inline command, you probably want to break it off into a separate script. If you want to background something, make sure to use our special CircleCI background syntax instead of an ampersand, because of the way we run things. Basically, each command is run in its own shell, so ampersand won't work like you expect. So beware of that. And also, sometimes you have to quote things. Even if it would be valid bash, it may not be valid YAML, so it needs to ultimately evaluate to a YAML string. So keep that in mind. That's just a few examples, lots more in the docs, and I'll take questions in a minute. Couple quick references, and then we're done. Greycat's wiki, or mywiki.wooledge.org. This is great. This is such a great bash reference. He has an FAQ and a guide, and it's basically where I get all of my bash tips and tricks. Those are the tips and tricks for the tips and tricksters. And then JQ is great. I mentioned that. Making the rounds, heard some of you mention it already. I think some people know about it. It's just great. Check it out. And then this talk, all of this is on GitHub. So I think that's it. I'll take questions. arg parsing, I have a recommendation, I think, which is to, rather than doing lots of arg parsing, err on the side of passing in environment variables, especially that syntax of, come on. What? OK. This kind of syntax of, like, let's say, foo equals bar echo $, foo. No, that doesn't work. OK, let's try this. There we go. What am I saying? So that syntax of passing environment variables, just saying x equals y, y equals z, whatever, before calling the program is a great, just kind of quick, low energy alternative to arg parsing specifically. For other things like function reuse is like one of the hard things in Bash, or one of the things that it's just not amazing at. That wiki that I mentioned, the Greg's or Greycat's wiki, has some great, a great limitations of Bash section that talks about things that it's just not great at. Floating point numbers it can't really do. Just reusability in general is not amazing. That's kind of where maybe you want to write some programs or some separate utilities that live outside of your scripts. Or maybe you have, like, in a project or a repo, maybe you have, like, a file of stuff that you source into all your scripts or something. But if you go much beyond like a thing that you source into your scripts for a repo, you're probably going to quickly, like, exceed the limits of Bash. But yeah, I guess that's my main thought. So the ones that I've seen are use some convention, some convention to do something like my function, and then just say, like, maybe write a little comment or something that says writes, foo, and then I'll say foo equals whatever. And because there's just one big global namespace, you're just kind of keeping track of what functions write to what things. This is, yeah, so I've seen that. I don't think it looks terrible compared to any other programming language where it's like, what are you doing with all these global variables? But it's like, it's a Bash file this big, and, like, it's not, it could be acceptable. Another one is, I forget the syntax off the top of my head, but, well, one slightly fancier version of that is, instead of just saying that this function writes to foo, you could say that this function writes to, like, underscore my function, or something kind of like tied to the function name with some naming convention, so that you kind of know, like, it's just going to be used by this function. It's just a tool to get the output out of this function. Another is, I think, a Bash version 4 or something feature called namerefs, which is it lets you call a function like some function foo, and then the function will get past the foo string, and it will write into the foo variable, a variable named foo. So it's kind of, it passes it in. So it would be something like, I may be mildly off on the syntax, but it's something like declare -n. It doesn't matter what I call it, right? It can be bar, and then I forget the syntax, but there's a way to get that reference to that variable and write into it. Kind of like how you would call a C function and pass it a pointer to an array and say, OK, I know it's going to write into the array that I just passed it. So that's another option. But to me, it's just, it only works in Bash 4. It still doesn't actually totally solve the namespacing problem, because, yeah, it's still kind of all in one global namespace. And I like the baby programs, just way to think about it. Another benefit to namerefs is that they don't create a subprocess. And some people say that, oh, there's this speed advantage not creating lots of subprocesses. But, like, how fast is Bash going to really go? We're not doing, like, fast Fourier transforms in Bash. So thanks, Laura.